Okay, so now we're dealing with joint A. I've gone ahead and drawn the joint here, and I've drawn in the forces that represent RAX and RAY. Those are the reaction forces we have, okay? I've also gone right here and gone ahead and found this angle at A. Alright, look and see, this is the imaginary right triangle that I used. I'm tracing it with my cursor right now, and you can see that the opposite is the height of the truss, 6 feet, okay? And then the adjacent is this dimension here in the figure, and that's 8 feet. Alright, so the arctan of that would be 36.9 degrees. Alright, now I need to draw in forces that represent the member AB and the member AD. Okay, if I look at my truss here, I know that I have this A reaction force going up, and I have to have a Y force to counterbalance that. Okay, AD is all X, so that means that AB has to have a negative Y component. So when I draw that in, alright, like this, alright, I drew it with a negative Y component, right? And since I drew it with a negative Y component, it also turns out that based on the way that's drawn, that has a negative X component too. So this is a positive X, this is a negative X. I don't know which one's bigger, really, but I think probably that AD, to balance out, is going to need to go this way, alright, away from the pin. Alright, so let's go ahead and draw it like this. Oops, I drew it backwards. Okay, so that's the force right there. Alright, so now I've drawn that force in as well. Alright, so you can see then that we've got this angle, 36.9 degrees. We've got our forces here, and let me label them for you. Okay, this one's going to be FAB. This one will be FAD. Alright, so just be sure you can see those. Alright, so let's go ahead and write our equations. Okay, we're dealing with a point here, so we only can use sum of forces x and sum of forces y. We can't use moments at a point because all the perpendicular distances would be 0. That's equal to 0. Okay, so let's start with sum of forces y, and here's why. In sum of forces x, I have 2 unknowns. Okay, I can't solve it directly. But if I do sum of forces y, I only have 1 unknown, and I can solve it immediately. Alright, so I've got my RAY is positive minus my FABY, and that's negative. So all that's equal to 3.33 kips minus FAB times sine 36.9 degrees. Okay, so that means FAB is equal to 3.33 kips divided by the sine of 36.9 degrees. And that means that FAB is equal to 5.55 kips. Okay, now we drew FAB pointing towards the joint. Look here, we said pointing towards the joint means it's in compression. So we have to write a C after it for compression. Okay, so now let's go back and do sum of forces x, because I know RAX, I know FAB, so I can find FAD. This is equal to 0, not O, 0. Okay, and so that's going to be 2 kips plus FAD minus FAB, well, we know that's 5.55 kips, times the cosine of 36.9. Okay. So we have FAD is equal to got to do the math here, 5.55 times cosine 36.9 minus 2.44 kips. And when we look at that, we have drawn that in pointing away from the joint. Away from the joint means the member is in tension, so we have to put a T. It's very important to note you have to put those forces on there. Alright, so that gives us joint A.